Don't say anything you don't want to hear because you're laying on the video, okay?
Gotcha.
They can't see you, but they can hear you. All right, here we go. We're going to write as an inequality. Now, I did not emphasize this yesterday, but we did talk about what that means. That is interval notation. On the number line, what would that look like?
2 separate dots.
2 dots, one at 4, one at 6. And what about those dots? Are they open or closed?
Open.
Why are they open?
Parentheses.
Parentheses means open, brackets means closed. Okay? And then we shade everything in between. Now we're going to write that as an inequality. That means we're going to write it with less than or greater than symbols, inequality symbols. When there is only one piece of the number line shaded, as opposed to a picture like this, we have 2 parts shaded. When there's only one piece shaded, then you should only have one inequality written on your paper. X is between 4 and 6. When you write a compound inequality, when you write one inequality that expresses 2 different ideas, bigger than 4, less than 6, always use less than symbols. It's very simple to do. Write down your 2 numbers, put X in between, and then use less than symbols. This is the inequality for this thing. Okay? All right, so what would the next one look like? Close, here's my number line. Close dot at 6, and then
shaded to the right.
To the right, doing a positive infinity. So what would be the inequality, the thing like this, that describes that?
X greater than 6.
X is greater than actually or equal to 6? Because that was a colored in dot because it had a bracket. The next one is an actual number line. Okay. What would that interval look like? Interval notation. Parentheses, -1, comma 5, bracket. There's your interval. But your directions say write as an inequality. So there's only one section shaded, right? So put down your -1, your X, and your 5. Always use less thans. -1, X, 5. And then, because that dot is colored, we'll need to put in or equal to on that guy. Are you okay with that? All right, now the next section goes the other direction. It says write in interval notation. I would like to have you work on that while I'm checking your papers, your pink sheets, and maybe come to the board and put them up here for me. Remember, oh, I've never told you this, but in this class you never have to come by yourself. So if you want to bring a friend up here, but let's look at 4A, 4B, and 4C. And your job is to put them in interval notation. So would you do that for me while I come around and check your signatures? You don't have to, that's up to you. I want you to write interval notation. If it helps you to draw a picture of it, that would be great. Okay, so you got it. Good deal. Are you signed? Okay. You signed, Sweet Pea?
No, my parents.
Thank you.
That's a major problem. All semester, Nick.
You signed over here?
Yeah.
You signed? Okay, get it signed. That's what it counts. Okay, get it signed. Get it signed.
No, I thought you know what it is. The actual, that's but just write that. Is that not interval notation? This is interval notation. That's already interval notation.
No, it's not. It's like with the parentheses.
What's the name for additive inverse?
Yeah, I don't know about what.
That's messed up.
I don't remember what 5 is.
Oh, what's additive?
I don't know. I'm trying to think of what it is. I know, like, I know we've done it.
The additive.
I hate it.
Woo! I did nothing on the butt kill brain cells. See, I think all your brain cells are gone. Like where they. I mean, I didn't get like a tutor or anything this summer. Like I have done in past summers, so.
Because I didn't read all of my summer reading.
It's because of what you do on the weekends kills your brains.
Alright, did I get everybody,
My brain said
and did everybody sign this? Okay, alright. Let's see how you did.
Oh, we were supposed to go up? I thought you were like gonna, like,
No, this isn't my grade. You guys have been charged. Let's get it done. Here we go.
I got so excited to both of my papers up here. Sure. Touch me. It's a bracket. Oh, right. Yep. And then.
All right, what do you think about what's on the board?
I think
Do
they're
you agree
right.
with that? Are you okay with that?
Yeah.
So I'm assuming at some point, relatively shortly, there'll be a quiz in our future, and you're gonna have to do interval notation. You're okay with that?
Yep.
Everybody's got it.
We Gucci.
All right, now we're switching gears then, when we look at number 5. Now we're talking about additive inverse. Does anybody have any idea, good work by the way, and thank you for coming up and doing it. Does anybody have any idea what we mean by additive inverse?
Yeah, something to the
The
inverse.
opposite. That's it, the opposite. So anytime it says additive inverse, we want the opposite. So what is the opposite of -3 plus pi?
3 minus 5.
The opposite would be 3 minus pi. Because if you're the opposite, it means when you add them together, they cancel each other totally out, like 7 and -7. So if we want to cancel this out, we need a +3 and a -pi. Beautiful. What's the additive inverse of 16?
-16.
-16. All right, use the distributive property. Okay, I think we know what that is, don't we?
Yep.
What do we do? Here's problem A. What do we do if we're charged with using the distributive property?
Multiply.
We distribute, right? We multiply 3x, oh Lord. What's 3x times 4x? 12x squared, nicely done. But don't forget, you need to take the 3x times the 2y, which would give you 6xy. Perfect. Look at B. I have said use the distributive property. You're looking at B and saying, well, Well, Ms. Ford, there's nothing to distribute. The distributed property goes both ways. So not only do you put the number in, but the distributed property also takes the number out. So somebody said GCF. Yeah. What can I take out of here? The only thing you can take out is an X, and what will you have left?
5x minus 8y.
5x minus 8y. You guys are really sharp. Good job. We call that factoring. And factoring is the same as the distributed property. It just goes the other direction. You okay? Here's what I'd like you to do then. C, D, E, and F. Give them a shot on your own, consult with your neighbors, and then come up and put the answers up here for me. C, D, E, and F in number 6. When you think you have one, just come up. Only one per person, though. We want to give everybody a chance. Now, take a moment and check what's on the board with what you think the answer is. What do you think about C? Whoever did this looked at it and said, well, looks like I can take out 2 A's and a Z from every term. And if I do that, if I take out 2 A's and a Z, the first term will only have an A left. And the second term will only have 4 Z's left.
Would you break that down, or like make it a squared z times a plus 2 squared, or would you keep it like that?
Oh, I see what you're trying to do. That's a plus sign.
So only if it's minus.
Yeah, it doesn't break down anymore.
Yeah.
All right, is everybody okay with that? Any other questions about that one? All right, this was a distributive, pure distributive, so we multiplied through. Did everybody get x cubed here?
Yeah.
Because we times an x squared times an x. This was another factoring one. Did you notice? 32, that's a pretty big number. Maybe you can take a 32 out. And then here we distributed. What's going to happen on this problem if we're not careful? We'll mess this up. Whoever did this did not. This is perfect. But remember, when you distribute, you take the negative times the negative. That's going to give you a positive. 21. Beautiful. We good? No issues? All right, let's look at part 7. This is a little bit crazy, our properties of exponents.
Yeah, I thought she was like trying to catch somebody.
All right,
She's
7A, here we
Yeah.
go. 7A, here we go. What are you gonna do with those X's? Cancel them. And if you just think about it for a minute, kids, you got 3 X's on the top and 2 on the bottom.
Mhm.
So visualize that. 3 X's on top, 2 on the bottom. They're gonna cancel, right? And what are you gonna be left with? 1 X. And where's it gonna be? On the top or the bottom? On the top. Now look at your Y's. Same idea. There's 4 of them on the top and 5 of them on the bottom. They're all gonna start canceling out. You're gonna have 1 left. Where's it gonna be?
Bottom.
On the bottom. Don't make it hard. It's easy. Now the next one is crazy because it has this negative exponent. Make Mr. Miller proud. What do you do with that negative exponent? It means the entire fraction will turn over. So we're going to start by writing this like that. Remember what negative exponents do. Negative exponents move you from the top to the bottom or the bottom to the top. So if you put a negative exponent on a fraction, it's going to take whatever was at the top and put it on the bottom, and whatever was in the bottom is going to go to the top. Now what do I do with my exponent now that it's positive? I distribute it. That's kind of yeah, we distribute it. So we're going to take everything in here to the second power. So what will I have? X squared, y squared, over 9. Oh my, look at this next one. I see a 4 here and a 4 here. Can I just cancel them out? Why not? Yeah, you're doing something to this one up here on the top, and you have to take care of that first. So I guess we'll take care of that. What would this equal? 16 x to the 4th. And then of course I still have my y to the 5th. Now can I start canceling things out? So what happens? These are going to cancel, right? Leave me with a 4. All right. X to the 4th over x squared. X squared on the top. And can't do much with that. There we go. What a mess. It's a long one. We can do it though, I'm pretty confident.
Yeah, don't you send the negatives to the other side? Or like you send the top negatives to the bottom?
That's exactly right. We gotta move those negatives around. So, anything with a negative exponent is going to change position. So, see this x squared? It's coming down. See that y cubed? Coming down. Now what about that z? Stays up there. How about this x to the 4th? Stays down. Goes up. stays down. What do you think? You all right with that? Now we got to put stuff together. So if we have more than one x, we have to combine them. So I see two x's, and they're side by side, right? What, if I have an x squared and an x to the fourth, what do I really have when I put those together? X to the sixth. Don't be confused, it's not hard. Think about x squared, x to the fourth. What do you have? 6 x's, right? X to the sixth. And it's on the bottom because that's where your x's are. Now your y's are different because you've got them on top of each other. So you're not going to put them together, you're going to cancel them because they're on top of each other. So what's that going to be? Y to the fifth over y to the third.
Y squared on top.
Y squared on the top. It's on the top because you have more y's on the top than you have on the bottom. Now your z's. We have 1 on the top and 6 on the bottom.
Z to the fifth on the bottom.
So we're going to have a z to the fifth on the bottom. So it looked really bad, but it wasn't that bad of a problem. Can somebody just tell me the answer to E? That one you can pretty much do. Colleen? X to the sixth over 27. Because what do we have to do? We have to do 3 to the third. And 3 to the third means 3 times 3 times 3. X to the sixth over 27.
Oh yeah.
It's my job to stand up here and blab. It's your job to stop me if you have a question, okay? X to the sixth over 27. All right, this last one, what about it? Tell me what you want to do with this problem.
Flip it over.
You got a fraction to a negative power, so we'll start by flipping it over.
X squared over 4.
X squared over 4. Everybody good with that?
Yeah.
All right, we got some more stuff to do, but before we do this, I'm going to give you one problem, one big exponent problem, and I want you to try to work it out. So, I don't know if you have room on that paper, if you have to take out another sheet of paper. If you have room, you can squeeze it in there somewhere. I just want to give you one more to practice. Take a minute, work through that. One of the awesome things about math, and there are many, but one of the awesome things about math is you can always do every problem in different ways. So I want you working on this problem. Squeeze it in there somewhere. Uh-oh, someone lost your heart.
They're all over the lockers.
I know. I don't have a locker, so I didn't get one.
You can take it from mine.
It's okay, I got this
I
one.
don't use my locker.
You don't?
I do not.
I need something else hanging on the wall there. you did, no, you already do that, but you do wanna, combine your, x's and y's. If you have x's over x's, y's over y's.
I got 9 over 16 x to the 6.
This is the hard one, isn't it?
6 y to the 6.
No, not really.
Maybe oh no.
Some of yours are geniuses.
Oh, what are you doing?
All right, I need to hear from somebody how to start it. I'm going to say this again. There's more than one way to do the problem. So we're going to do it however the person who speaks up suggests. But that doesn't mean you're wrong if you start it another way, because there is more than one way to start this problem. How did you start it? I'm going to start trying to learn your names. How did you start it, Jake?
I started by distributing the 2.
Okay, so Jake said, look, I got this big ugly fraction, everything's being squared, so I'm going to square everything. All right, let's do this carefully. Now, when we say we're going to square everything, that includes the 3 and the 4. So we're going to have a 9 and a 16. Now, when you square x squared, that means x squared times x squared. So that's xx, xx. So that's going to be x to the 4th. For those of you that remember the rules, when you raise a power to a power, you multiply the exponents. So now I've got y to the negative 5th twice. So that's going to be y to the negative 10th. Now I've got x to the 5th twice. So that's going to be x to the 10th. And y to the 7th twice. That will be y to the 14th. So again, you didn't have to start this way, but that's a perfectly fine way to start. You aren't done though when you get here, because you've got 2 x's in your problem. They have to be put together. 9 and 16 don't cancel. So I'm going to have 9 and 16. Now what about x to the 4th over x to the 10th? What happens there? X to the 6th, excuse me, on the bottom. Uh-oh, that's a negative exponent. It's coming down. I'm bringing down 10 y's. But what's already down there? 14, which is going to give me a total of 24 y's on the bottom. How many got it right? Good work. Anybody have a question about that? That's as hard as they'll get. Till we put in fractions, fractional exponents later.
Since the y is to a negative 10, why wouldn't you like flip the fraction like we did before?
Great question. We only flip what is attached to the negative exponent. So if this were x squared y to the negative 10th, I'm just making up a smaller problem. That would be x squared over y to the 10th, because only the y has the negative exponent. If it were x squared y to the negative 10th, then it's, well, let me put it over something. Then the whole thing's flipping, because everything has the negative power. Here, it is only this little piece that has the negative, so he moves. Anything with a negative is going to move. If the whole thing has a negative, then the whole thing moves. Does that make sense?
Yes.
All right, what's next on our little sheet here? Scientific notation. Oh boy. We all took chemistry, right? And don't they spend a lot of time in chemistry going over Scientific notation. So can you tell me what this number would be in scientific notation? 3.14683. Remember, when you do scientific notation, you only have one digit before the decimal point, right? So 3.14683 times 10 to a power. And how do I figure out what the power is? How many places did I move my decimal place? I moved it from here to here. So that's 1, 2, 3, 4, 5 places. Now, Mrs. Ford does not know what the rules are about moving left and right and positives and negatives on those exponents. All I know is that if it's a big number, the exponent will be positive, and if it's a little number, the exponent will be negative. This is a big number, so its exponent is going to be positive 5. The next one is a little number, so its exponent is going to be negative. Again, I can only have one, I must have just one number before the decimal. That involves moving it one spot. So there's my number in scientific notation. Now the next ones are the ones that get hairy. Sometimes, not always. When you're doing arithmetic with numbers in scientific notation, it is generally easier to deal with all of the regular numbers first. So deal with these guys first. So we'll just take out our trusty calculator and we'll multiply 3.16 times 1.43, and then we'll divide by 1.23, and I get 3.67 if I round it off. Okay, so everybody understand? I'm multiplying these two, and I'm dividing this one. Now, what about the tens? What should I do with these two? What are your thoughts on that? Well, somebody said it, I think. Adam? What's 5 and negative 8? Negative 3. So on the top, I have 10 to the negative third. On the bottom, I have 10 to the negative 10. What do I do in a division problem?
Subtract.
I subtract the exponents. Negative 3 minus negative 10. Positive 7. Now, if that's confusing to you, in the beginning, we had 10 to the 5th, 10 to the negative 8th, and 10 to the negative 10. If you move the ones with negative exponents, you have 10 to the 15th on the top and 10 to the 8th on the bottom. When that cancels, what will it leave you with? 10 to the 7th. So if the way we did it the first time confused you, and the way we did it was, we took these two and added them, 5 and negative 8, and we subtracted this one because it was being divided. If that confuses you, then just do it like we've been doing it. Negative exponents get moved and combine and cancel, and you're going to get 10 to the 7th. The next one has a little bit of a complication in it. It looks like an easier problem, but it actually has an issue. What shall we do first? Multiply those two numbers together. All right, so we have 3.85 times 4.96. 19.096. How many tens do I have all together? 23. Now, you want to put a circle around that answer? We done? What's wrong with it? Not one decimal place here. We got 2 decimal places here. That number's got to be changed. Everybody catch that? Wasn't an issue over here. This one came out perfectly. This has got to be 1.9096 times 10 to the something, and the question always becomes, is it going to be 24 or is it going to be 22? So I want you to use your logic. Whatever this is supposed to be the same as this one. You made this smaller, right? You went from 19 down to 1.9. You made this smaller. If you made this part of the number smaller, what do you have to do to this part? Make it bigger to keep everything in balance, right? So if this came down 1 decimal place, this one's going to go up 1 decimal place, and it's 10 to the 24. Okay? All right, one more section. We'll take a little, just get up and move around, do some practice work. One more section. Which property is illustrated? You have to know these. This will be on your test and quizzes coming up, definitely.
Are quizzes surprise quizzes? Or
Most of them are announced, but I've dropped some hints. We'll be having one soon. I've told you already you're going to have to do interval notation, right? And I'm telling you, you're going to have to know some properties. So look through the list. Do you know any of those right now?
Distributive.
A is distributive. Okay, so let's all write distributive. We got that right. Do you know any of the others? F? What's F? No, F has a special name. It does involve multiplication. It's the identity. It's called the multiplicative identity. F is the multiplicative identity. And if you want to abbreviate that, you certainly may write mult-ID. That's the multiplicative identity. That is letter F. We're going out of order, but that's okay. That's F. Anybody see another one on there you know or want to guess at?
Is E the associative?
Is E, let me find E, is E associative? What does associative mean? It means you have reassociated, you've regrouped. So we have 6 times 4 times 3 and 6 times 4 times 3. Did we leave everything the same?
No.
And just, did we leave everything the same and just group differently?
Yes.
That's associative. And since we're multiplying, we'll say associative of multiplication. Beautiful. If you have left everything the same, except moving the parentheses, then it's associative. Good. All right. What else? Anybody see another one?
Is C associative?
Is C associative? Let's look at C. Now, just about 30 seconds ago I said, if you have left everything the same and moved to the parentheses, it's associative. So let's look at C. What happened in C? Is everything exactly the same?
No.
No. In fact, things are in a different order. what property is it that we are allowed to change the order in? It goes with associative. It's the other one.
Distributive.
No. Commutative. This is the commutative property. And this particular one is for multiplication. Now, you'll look at me and say, whoa, Mrs. Ford, how do you know it's multiplication? Because there's a plus sign in it too. I didn't change the order of the addition. X plus Y, X plus Y. What did I change? The order of the multiplication. This one was 6 times, parentheses. This is parentheses times 6. Commutative. What's the difference between commutative and associative?
Change order.
Commutative changes the order. Associative leaves everything in the same order, just picks up the parentheses. All right. Did we do B?
No.
What's going on there? It's not associative. What's in the parentheses? X and Y. Same things in the parentheses. We didn't change that. What did we change? The order of the addition. So what property would that be?
Commutative addition.
Commutative of addition. Did we do D yet? Additive identity. D is called the additive identity. If you add 0, you get the identical thing. Additive identity. G is the next one. Anybody want to take a wild guess what that is? Notice? Very close. Actually, none of the properties involve subtraction or division. So, because subtraction is adding the opposite and division is multiplying by the
Inverse. The inverse.
multiplicative inverse.
Yeah.
G is called the multiplicative inverse. Anytime the reciprocal is involved, it's the multiplicative inverse. How about H? No, actually, we've already talked about it. That's distributive. H is the distributive property. We're just going backwards on it, right?
Yes.
It's the distributive property, and we're just going backwards. We're not doing transitive right now. We're only doing this in chunks, so we don't have to be overwhelmed. So let me run through and make sure you got all the answers. A was distributive. B was commutative addition. C was commutative multiplication. D, additive identity. E, associative multiplication. F, multiplicative identity or identity of multiplication. G, multiplicative inverse. And H was distributive. Okay? All right, when everybody stand up. Take your mind off math for just a minute.
Just a minute.
Yeah, we don't take our mind off math for too long. Who will share some fun fact that you did this summer? Anybody do anything fun this summer? Yeah.
I played some basketball in the driveway.
Oh.
That's not as fun as I thought. Yeah.
Yeah.
I got something.
Yeah, what?
I learned how to wakeboard.
Oh, that's wonderful. Well, fun fact about Mrs. Ford, back in the day, I loved to water ski. It's my very favorite thing in the whole wide world. It rivals math. I mean, I really love to ski. And back in the days, I was a competitive water skier. I actually traveled around, But I trick skied. When you compete in a water skiing competition, there are different events, and we trick skied. But I've never been on a wakeboard in my entire life. I've been on what we used to call a glide slide. When I barefooted, I came off a glide slide. But I've never wakeboarded. I have no idea. I would love to try it. I love the paddleboard and that stuff. I'd love to do that. So if you have a boat and want to take me out sometime, that would be great.
I wish I had a boat.
I know a lady that's like
I would totally
90 years old that still skis.
That's the problem when you're boatless. You just kind of have to wait till somebody else. Anybody else do anything fun? What sport? Golf. Golf. Are you in contact?
So I got 2 offers over the summer to tack on the
Uh-oh, we're getting some scholarship offers up here to play golf. Good luck. Good luck. When will they make a decision? Soon?
I'm trying to get it done before the first second period, which is in October, just so I don't have stress.
Don't want that stress.
Regis in Denver and then USF.
So, if you had to get one right now.
Denver.
All right, one more. I need one more sharing.
Oh, what did you do this summer?
Did anybody take a family vacation?
Yeah.
Where'd you go?
I went to Colorado, but I went with my sisters, but not my parents.
Your parents, how many sisters do you have?
I have 5 sisters. 2 brothers.
Bigger than you?
I have a twin sister, and then I have 3 older sisters.
And you all went to Colorado. For how long?
Just about like 5 days.
Oh, we're gonna go in about 20 or 25 minutes. Okay? All right, let's sit back down and get ourselves focused.
That's the problem with long periods.
Oh, yeah.
And they want to keep going.
Normally, on a normal day, I think I told some of you this, we would go to lunch in the middle, and that would really break it up, and that would be perfect. But I have an oncologist appointment that I have to go. Actually, I have to go twice today. So this first one, I got to run over there and give some blood, and then I'll go back later for the actual appointment. But so we have to do this. I'm sorry, but normally we'll eat in the middle. Today we're eating lunch. All right, we're back on page 2. And we are looking at, we're on page 2, and now we're doing P2.
Wait, so if we went to the middle, what would happen on the test?
We would do what we're doing now. We would take the test and then go to lunch. Or I might give you the choice. I might say, would you rather eat first and use that time to cram or whatever, and take the test, or you want to go to the opposite way? Okay.
I can probably answer this soon, but I take my test in extended time.
Mhm.
What would I do?
You'll do whatever they tell you to do. You'll bring me the form, I'll turn it in, and then it's up to you guys to figure out. I don't know.
Okay.
Okay? All right, so now everybody's looking at section P2 on page 2, and I'm asking you to fill in the blanks. Now, these are vocabulary words that you should already be familiar with. I'm sure you are. What do we call this line right here? That's your y-axis. What do we call this line right here? The x-axis. What do we call this point right here? The origin. So we're filling in the blanks. Vocabulary. Now, these are quadrants. That's what the Q stands for. 4 quadrants. How are they numbered? And when we number them, we use Roman numerals for the quadrants. And how are they numbered? 1, 2, 3, 4, but where does the 1, 2, 3, 4 go?
1 is top right.
1 is right here. That's quadrant 1. Which one's this?
2.
This is 2. This is 3. And this is 4. A question might be, point A a positive x and a negative y. Which quadrant? Positive x, negative y.
Oh no. Four.
I hear 2 and 4.
Four.
Positive x, negative y.
Four. Oh.
That would be quadrant 4. These are positive x's, right?
Mhm.
Right is positive. Down is negative for the y's. What's this whole shebang called? You're supposed to fill in a blank out there that says, what is all this called? What is this? It's called the Cartesian coordinate plane.
Oh, we're gonna have to remember that word.
You are. Rene Descartes, one of the great mathematicians. The Cartesian coordinate plane. Later on in the year, like January or February or something, we'll be talking about a different coordinate system. And so we'll want to keep them straight because we'll have a coordinate plane there too. This is the Cartesian coordinate plane. Anytime x and y are involved, you're thinking Descartes, Rene Descartes. All right, let's look at number 2. Any idea? Is this thing still running?
Yeah.
They have a limit on how long they go, but I see it's still going. Okay, any idea what we're talking about in problem number 2? What this means? Any idea?
The line maybe.
Sort of. The distance between the 2 points. What is the distance between the 2 points? Does anybody remember how to find the distance between 2 points? Yes, ma'am.
Is it like y squared minus y1 over x squared minus x1?
Okay,
Something like that?
you got something going there. It's not the distance. You're thinking about slope,
Oh.
and that's good. It's all kind of all related together. Anybody have another idea?
No, never mind. Hold that.
Oh, is it the square root?
It's the square root 1. We need the square root.
Something sounded right. No.
Now, what do we do under the square root?
Oh, there used to be a song to it.
Oh, no, you're thinking of the quadratic formula.
Oh,
No. That's negative.
It's all coming down.
Cross your mind. Yeah, no. This is something different than that. I'm going to subtract my x's and square that.
I got you.
I'm going to subtract my y's and square that. For those of you that want to memorize a formula, it looks like this. Nobody is ever going to ask you to write down the formula. You need to be able to use it. This looks so complicated. The idea is very simple. Subtract your x's. These are your x's. Subtract your y's. Square them and add them up. So -1 minus 7. Please get the arithmetic right. -1, -7. -8. Three minus 1. -8 squared is 64. 2 squared is 4. Added together is the square root of 68. Anybody feel a little bit twitchy? about the square root of 68?
Yeah.
We just feel a little unsettled because what do we need to do with that 68? We need to simplify it. How does the square root of 68 simplify? And I'm not talking about typing it in and getting a decimal. I'm talking about reducing the radical. Backwards. 2 root 17.
2 and 34.
He
Sorry, 2 root 17,
said
that's what I had.
2 root 17. Now, how did he do that? Do you know how he did it? He's right. Do you know how he did it? He said 68 is 2 times 34, and 34 is 2 times 17. So I have a 2 and a 2 and a 17. That's what makes up 68. And when I do a square root, I look for groups of 2 to bring out. You good?
Yep.
All right, do the next one on your own. That would be letter B. Do it. We take 2 minus negative 5. Oh, please be careful with the arithmetic. What's 2 minus negative 5?
7.
7. Squared is 49. 6 minus 1, that's an easy one. Squared is 25. Did you get the square root of 74? Now, anybody trying to break down the square root of 74? Of course you tried, but it doesn't, right? Because it turns out to be 2 times 37, and 37 is prime. Got it? All right, one more on the back side. Let's do it real quickly. We'll talk about midpoint, and then we'll be done for the day. C, we're finding the distance on the back side, so everybody's working on it. Tricky with all these negatives floating around. I got root 13. And I got root 13 because negative 8 minus negative 5, negative 8 minus negative 5 is actually negative 3. And when I squared it, I got 9. And then 4 minus 2, I got 2 squares 4 root 13. All right, number 3, we want the midpoint. Does anybody remember anything about midpoint? Okay, actually, there has to be some direction involved with that too, so it's actually a little easier than that. Midpoint literally means middle point. So I want you to think about how you find things in the middle. For example, you take a test, you get an 80. You take another test, you get a 90. When the teacher puts the grade on the report card, it's the middle of those two. How do we find the middle value? Always the middle value, add and divide by 2. We call it the average. The middle value is the average. So when I look at these 2 points, what is the average of -1 and 6? Well, do exactly what you just told me. Add them together and divide by 2. So -1 plus 6 is 5. Divided by 2 is 5/2. Now, if you'd rather put a decimal, that's fine. What is the middle y? Average the y's. 2 and 4 makes 6, and 6 divided by 2 is 3. There's your midpoint. Now, for those of you that want a formula, and remember, you don't need one because midpoint is just average, and you all know how to find an average. But if you want a formula, it's this. You add the x's and divide by 2, and you add the y's and divide by 2. You do B. Find the midpoint of B. Divided by 2. Remember, you add them and divide by 2. Remember, you're going to add and divide by 2. So add your x's, add the 2x values, and divide by 2. Add the 2y values, and divide by 2. And that will give you your midpoint, which is what? Or B? -7/2, comma, +7/2. -7/2, comma, +7/2. Okay? All right, oh my gosh. Have we crammed in a lot of information today?
Yep.
Yes. Over the weekend, I would suggest that you do the P1 homework and maybe even start the P2 homework. Remember, it's not due until we're done with P7, but kids, you've got to stay on top of it, okay? All right. Let me turn this video off, and